So now we're going to get on to actually running the example, what happens when we run the example and what the framework is doing. In this first video of this section, I'm going to talk about prepping the interaction, what happens within this part here. So recalling what we've covered as a brief summary so far, when the instrument identification application is running, when we press get ID, when we select an instrument and press get ID is picked up by the event processing loop and enqueues a message action 1. The main processing loop dequeues a message action 1 and runs this state here, this case here. And the first part of this is to prep the interaction, and followed by actually running it. This structure here is just a sequencing structure, and what it's basically saying is that everything in this frame has to finish before anything in this frame can actually start. Now that would be the case anyway, because this VI here requires outputs from the preparation VI in any case, but this makes it very clear what we're trying to do. So when I talk within the main blog about what the actual interaction, what the framework requires, and it will run through what we call command directors to actually run commands. So commands are inserted into the right command director, and the command directors are actually controlled by the interaction processor, which we see here. So when we want to, in this particular example, prepping the interaction, I'm after the instrument ID, and so I'm passing in an instrument name, and the instrument name has been selected in the control here, and we're passing that into a VI get ID. So let's have a look at that. Okay, so we pass in an instrument name, and I'm using a class called resource enumerator. This is part of the framework, and this is used to, one of its functions is to map the instrument name to an actual driver. Again, within the framework, drivers are the things that actually communicate directly with an instrument. An instrument is a subclass of driver, so an instrument is just a concrete instance of this whole abstract idea of drivers. The resource enumerator does different things as well. There's an abstract one here. It's capable of finding all the instruments connected to the PC, as well as implementing this function map to driver. Now map to driver is really the method that I have here, the VI I have here, is very specific to my setup here at home. What would normally happen is you would override, you would provide a subclass of abstract resource enumerator and override this method called getAllInstruments, which is used within map to driver. But let's just go back to that here. So we're mapping to driver, and if I look at that, this method here is taking in a driver name. I've originally called it instrument name from the name on the front panel here, and we want to try and match that to one of the instruments that is installed or connected onto the current PC. And getAllInstruments, if I look at what's been implemented on the resource enumerator, this is the only part of the framework that requires very specific setup from a user of the framework. In this case, you can see I've selected the instruments that I know about, that I would use here. Anybody using the framework would provide their own instruments, and the examples are here. There's not a lot to them. If I take let's say the power supply, all I'm doing here is being able to return the instrument alias. In this case, it's just a string, and the string says HMC 8043, and build driver settings mappings, which we'll talk about later. I'm just building an array here of all the potential instruments that can be connected. They don't have to be connected, but they could be connected to the system, and that's just an array of these elements here, because it's these things that I need to actually use to run the commands. So we get a list of all those instruments, and we we iterate over them, looking to match the name that's passed in from the control. Here you can see I'm passing it in twice. If we go into here, we can see that one of them is the alias and one of them is the canonical name. Now this is just how I've got this set up here to actually sort of pass it in this way, because I don't know whether the name selected on the control was an alias or whether it was actually the canonical name. I'm looking at the VI for this. So for the driver that we're looking at the moment, we pull off its instrument alias and we compare that to the alias name passed in, or we pull off the canonical name and we compare that to the canonical name passed in. If either of them match, we've recognized that driver. In other words, we've found the driver that we need to use for that string name. So we now have a driver to use to actually run through the command that we're interested in. So having got a driver, we know we can do something. And the first thing that we want to do is select a command. In this case, it's a scupy reset command, and that's another example of part of the implementation. Here we have the reset command, and these commands, when we set them up, all we need to do is to provide the get base command VI, which is the actual string command that we will run, and we'll see this shortly. And in this case, for the reset command, I've also created a method called postexec callout, which is a callout that will run after the command is actually sent to the instruments. And again, we'll come back onto that in a later video at the most appropriate time. But we take the reset command and we add the driver to that command there. We also take the IDN command and we attach the same driver to it. So we're going to send both these commands to the same driver. For the IDN command, because that's actually a read command and we expect a result from it, I want to capture the ID. The ID is created automatically by the framework, and we'll pass that out as a parameter. But these two commands, I'm going to add it in the order that's shown here to a command director, and the command director I've chosen is the single shot director. This will run each command that it's given just the once. The command directors that we have this single shot command director. The other command directors are subclasses of this, so they inherit some of the functionality of it. But we have a continuous director that will run the commands continuously without stopping until it's actually told to stop, and you would do that by pressing, for example, the stop button here, which would raise a stop event. We also have a repeating director which will run those commands a specified number of times. So for example, we could set it up to run those commands 10 times. And there's also the time director which will run it for a duration. So we could, for example, say run it for 60,000 milliseconds, and it will then just run through those commands until a minimum amount of time, 60,000 milliseconds, has passed. It's not wholly precise. It won't run it for exactly 60,000 milliseconds because the framework has to tidy up. It needs to run through that command set before it actually finishes. So the test is done at the start. If it had to run through, for example, 10 commands and it was already at 59,999 milliseconds, it would need to run through all 10 of those commands. So it might actually finish at 60,010 milliseconds, for example. But we add those commands in, and this is a preparation, remember, and we pass out the command directors as an array because we know that the interaction process requires a set of command directors to run through. And as I say, I'm also passing out the ID of the read command so that I can process its result later on. And we've seen some of that in the results handling loop. So processing the preparing the interaction here, we're passing out the command directors into the run interaction. We're keeping a track of the IDs of commands that we're interested in results, and these can be managed within the results handling loop here. The wait time I pass into the run interaction is the amount of time I want to wait in between the command director being told to process their commands. So it's not a wait time between commands, it's a wait time between command directors. I only have the one command director here, so a wait time is irrelevant. And I'm also passing in a notifier because I want the results to come back as a notification to be handled through this loop, as opposed to a state change to be managed within the main processing loop within results. And the flag here, the flag at the bottom, is telling the interaction processor to not expect commands to be injected whilst it's running. So what that means, and there's another example where I'll show this, the interaction processor will run through all the command directors and it will keep doing that until all the command directors tell it that it's finished, that it has finished doing what it's been asked to do. And once they're all reporting that they're finished, then the interaction processor is done, and it tells us it's done and it finishes its work. If we want to be able to inject commands into that process, we need to tell it to be prepared to handle those, so that if any of its command directors do finish and effectively that run has done, then we don't want it to stop because we might want to inject commands still. This just is a flag to say don't stop running until you receive a stop event. In this case, I have no intention of injecting commands, so I'm telling it not to worry about that. And we'll see some of this when we go into this into the run interaction VI and see exactly what's happening within the framework in the next video. So just to summarize then, what we're really doing here is we're preparing the interaction, we're setting up the command directors we want with the commands that we want to run before we actually tell the interaction processor to process those command directors. And we're going to come on to this in the next video.